Hey guys, welcome to Admiral 19A1 Chassis Restoration 2. Still plugging away a little bit on the earlier one I did that I got working pretty well. Still got a few old caps to replace and whatnot, but it's working quite well. I want to dive into the second one. This is the one that initially sparked rekindled my interest in this chassis. This is the one that I received via eBay recently. But the reason I went with the other one first is that this one had a showstopper, which is a transformer that's missing. And I now know, from having worked on the other chassis, that this is the magical horizontal transformer that lets them use a single triode to do a horizontal oscillator and a balanced output synced to the incoming signal, so critical. I'm going to pull one out of a spare chassis I've got. And the picture tube, the base is really loose and some of these pins are kind of wonky. And it's been transplanted, I do believe, from a Motorola set. But it does test okay. And underside, it's virtually all original. So having gained some experience on the other one, I'm curious to see how this works. And if you recall, on the first one, I spent the bulk of my time fixing up the tuner, which had a shaft broken off on it. And this tip had been like broken off and a new one welded on that was a different shape and size. It was weird, just weird. So anyways, we should not have that issue with this one, although I can see the screw is loose on this, so the channel clunker. If I hadn't noticed that, it probably would have given me trouble if I tried to change channels. Anyways, we're going to do the same thing on this one. We are going to visually inspect it, especially the power supply electrolytic. The main one is this guy way down here. And I suppose I will... So in the other one, it had already been clipped out, and some new caps had already been tacked in ages ago. I tested the tacked in, or the replacement caps, and those were bad. So before I even tried powering it up, I had already replaced the main power supply electrolytics. This time around, let's try to reform them. Let's see if we can coax some life out of these original caps. So, first thing I gotta do, well, I guess we could start with the cap first, because I can test them and try to reforming them without having to plug the set in. And while it's reforming, if it's going to reform, it's going to take a while. While that's going on, I can scavenge my coil out of the other chassis. First thing we're going to do is refamiliarize ourselves with the schematic. Very basic, straightforward, no-nonsense design. Got our EC interlock, power switch primary, power transformer, secondary going to a 5Y3 rectifier, electrolytic, filter choke, electrolytic. These are the two we're going to be focusing on right now. They are both down here. Yeah, we got a little spider corpse to keep us company too. I believe this is one and that is the other. I'll have to confirm that. Can simply trace these wires up to the filter choke, which I do believe is that guy right there. Well, I'm a little puzzled. I'll show you why. I thought these chassis were essentially identical, but while I was working on this one, I noticed this odd thing. A terminal strip with no components, just tie points for some various wirings. This doesn't have it. I'm pretty sure that's the filter choke. I focused on that because I had to replace one of the wires going to it because it was super crumbly and stiff with the wire insulation. But this doesn't have that. I think the only reason these are here is because the wires off of this filter choke are short. So all that goes to this is the two wires from the filter choke are going here, and then the other wires go off to the rest of the set. In this one, maybe the filter choke wires were... Oh, no. Scratch that. It's located over here. Huh. How strange. This also has a terminal strip there, but it's a little different. It's only got one lug. Although one side of it is going over to this. I'm very confused at this point. Well, let's just go with what it is. It's basically the same thing. I can see that right now. The two wires from the filter choker go into these two lugs. At some point, for some reason, they moved it from this location over to there, or vice versa. I keep forgetting. This is the earlier one, by about 7,000 serial numbers. Alright, anyways. Admiral was pretty infamous for doing production run changes. Some chassis have over 20 production run tweaks. Interesting, we've got some notes down here. I wonder if these were the high voltage readings. Kind of looks like they are. Interesting. Like maybe that's what they measured and that's what it's supposed to be. There was a little bit of work done on this. One cap was replaced. That really lousy soldering joint. That's about it though, really. I think everything else is original. Anyway, well, you know, maybe this has been replaced. And as soon as I looked at it, I noticed that the solder joints looked a little sloppy. And now I'm looking at this twist lock, and it kind of looks like that has been unsoldered. Yeah, and the one over here, this is a replacement filter cap. Well, there's even better odds that it's still got some life left then. Alright, so, enough babbling. What I want to try doing is hook it up to a capacitor tester, and I want to know, can I do that as is? In other words, if I leave them hooked in right now and I put a capacitor tester on this guy, it's going to be going right through the filter choke over to the other cap. So they're both going to get hit with voltage at the same time. I'd really like to isolate them if possible. If I take this tube out and I disconnected one side of the filter choke, let's see, what's this going down to? No, it's not going to go to anything. And let's just go into a tube element, okay. And then the other side is probably going to all kinds of stuff. Alright, so to really do this right, I do need to isolate these caps. Well, first things first, let's identify which lugs are which. And if I'm lucky, they did such a lousy job soldering these on, if I just heat this up, all these white connections may just kind of fall off. So maybe it won't be so bad. Alternately, I could just plug it in and use the set itself to see if I can reform it. Decisions. Thanks to some lousy soldering, it was actually quite easy to get that apart. The one down here heated it up and the whole thing just came away as one blob. I wonder if they actually clipped that off of the original cap and there's still part of the original lug there and they just tacked it onto the new one. Other one similarly was pretty easy to get apart. Now you may recall on the other set they found some unused lugs nearby to put the new caps on. And this set has the same deal. There's an unused lug right here and another one over here. So I could do something similar if I need to. But anyways, so the caps are now isolated, both 30 microfarad caps, so let's see what we get. Definitely leaky at 100 volts, not surprised. And this is the first one. This is the one that gets the brunt of it when you turn the set on. So the idea is that if the cap can reform, that bulb will slowly go dim and go out when it hits 100 volts. And also when you go, this is a neon bulb, it's got two sides to it. It's kind of like a hat split down the middle. When I flip it to 0, it discharges the cap. So any charge that cap has built up will get discharged and the other side will glow. So if I go here, nope, nothing. So two things. One, if that light goes out, that's good. It means it's not leaky anymore. And two, when I go to 0, if we see the other side light up and slowly go out, that means it held the charge. It's entirely possible for the cap to completely dry out and it's got no capacity, no leakage, but it also isn't a capacitor anymore. It's basically just empty space and it's not doing anything. So both conditions are bad. Well, I'll just let this sit for a while and meanwhile I'll scavenge that coil, or transformer rather. And that would be this guy. That's what I'm talking about. Or is it that guy? I don't know. It's one of these two. I didn't realize there were two of them. Well, things are looking pretty good. Up to 300 volts, no leakage. And when I go down to 0, we have glowing on the other side, which slowly fades, so the cap is holding a charge. Go up to 300. Alright, now I'll try it on the other section, and I have salvaged the coil. The DC resistance checks out alright, so we'll get working on installing that too. Well, both 30 microfarad caps formed up to 300 volts, and both showed that they do have capacity. In other words, they are functioning as capacitors. I finished transferring over the horizontal coil. So I think we're ready to try a power up. I hooked up a speaker. I pulled it out of the cabinet, so it's the real, genuine Admiral speaker. And I got my voltmeter on B+. And, well, here we go. Oh, turn on my Variac. I'll put it in current mode so we can see how much current it's drawing, and here we go. Alright, it's drawing about 0.6 amps. We obviously have B+. Getting 275, it should drop as the tubes start conducting, and it is. Got a crackle out of the speaker. Current swinging around a bit, around 0.7, 0.8 amps. Tuner's got a nice action. Fine tuning is pretty seized up. I do have a signal source hooked up, so I thought we might get some reception. Oh, we're not doing a fine tuning shaft. It's getting a little bit better as I rotate it. And I don't see anything glowing on the screen. B+ is holding pretty steady. It's a little low. Alright, so I'm not going to get any sound, it seems. Let's see about getting something on the screen. There's brightness. Okay, I'll power this down for a moment to get out a high voltage probe and see what kind of high voltage we do or don't have. Now I had the same problem in the other set where the high voltage caps were super leaky. And until I replaced the main filter cap on the high voltage, we really didn't have anything. I would not be surprised if that was the same case again. I was feeling kind of optimistic though. I thought we might get some sound. We did on the other set. The little 6 kilovolt high voltage probe that came with my government surplus Fluke 27 FM. Let's see. And here's the main high voltage point. And yeah, we got a whopping 660 volts. It should be more like 4,000 or 5,000, so we're not going to get an image with that. This tuner feels so much better than the other one. It's kind of a shame after all that. Well, you know, so the other set had, it's a little bit earlier chassis revision. And it's a similar tuner. It's the same model number. And had the same thin disc for fine tuning. But the other one had a different spring retention system to hold this drum in. And this is the later design. And definitely think it's a big improvement. Much easier to turn. That's why these Admiral knobs get broken so often, is you need that shaft because you need the leverage when the tuner is gets kind of stiff. Not bad on this one. It almost sounds like it wants to do something with the sound. Alright. Well, that wasn't all that exciting, was it? At least nothing went up in smoke. So, a few things. One, there is actually an electrolytic on the sound. There's a little 4 microfarad electrolytic there. I could replace that. I can check some of these power resistors. Basically, I want to check some of the obvious faults there might be with the sound. Because if we get sound, then we know that the tuner's working and the IF. Let's see, this. Yeah, because this uses a common an air carrier IF. So both the sound and video go through the same IF. So if we get sound, we know that everything is good from the antenna terminal through the RF amp, the oscillator mixer, the 3 IF stages and the detector, and the video amp, and the audio IF, and the ratio detector, and the audio amp, and the audio output tube. So, in other words, if we get sound, we know that like 2/3 of the set is working. But it's not. So, there we go. Now, there's also the other electrolytic down here, and that is used in the sound circuit. So, another design feature you often see on more budget-minded sets is this. The cathode of the audio output tube does not go to ground. It goes to a filter cap. They use this biased in Class A operation as a voltage divider. So say B plus is 250 volts, the cathode might be at 125. And there's a filter electrolytic, and that actually powers the IF circuitry, which runs at a lower B plus, which is a really common thing. Higher B plus is for your output tubes and your vertical circuitry, but typically the IF runs at about half of the main B plus voltage, and this is no exception. So I have not checked this electrolytic yet, so that could also be an issue that would definitely affect the sound. A few things since we last left off. One, I went through and replaced all of the high voltage caps, all 6 of them, 5 of them rather. Why? Well, I replaced the main one, which on the backside turned out to be bubbling, and that got the high voltage 2,500 at the main anode. But I noticed when I checked it at other points in the high voltage circuit, it was much lower. So I went and took a look at some of those caps, and first what I looked at I noticed was really sticky on both ends. This is fresh meltage, so this thing was cooking while I was trying to run the set. And I also noticed, well, I noticed earlier that one of these was replaced, but it turns out that two more have been replaced too, because when I took a closer look underneath the wax, these are Motorola caps, and I could see that they were kind of sloppily tacked in. So a little bit more work has been done to this set than I had realized. I also checked some of the high-valued mega-ohm resistors in here. There's a string of 2.2 meg resistors, and the first one was measuring like 5.5 meg, so I replaced that. The others are all high as well, but not quite as bad. So let's give that a try as is. And I did replace both tubes in the tuner. I didn't check the ones that were in there, because I just wanted to quickly see if it would make any difference. So here we go with another power up. Oh, and I did check that yellow cap down here, that other electrolytic, that is a replacement. And the voltage in the cathode of the audio output tube is about 125 volts, which seems about right. It's about half of B+. Alright, now for the high voltage. It's weird. I don't have my ground clip hooked up. Oh, I can hear that's higher. Yeah, 4,500. Cool. I took care of that. I mean, those high voltage caps, they're just always bad. They're going to be. I mean, it's like, I've never seen one that was even remotely close to being good, so there you go. But we have nothing on the screen. Oh, wait, yes we do. Yes, we do indeed. Wow, that CRT is really crooked. Either we've got no vertical or no horizontal. This thing is so out of whack, I can't really tell. I hope it's at the horizontals. I mean, that's the transformer I just swapped out. Well, actually, I can tell. Of course I can tell, because there's a horizontal and a vertical centering. So vertical centering, changing now. So we have no vertical. Cool. Horizontal centering works, which means the horizontal oscillator is working, which means my transplanted coil is doing something. Having no vertical is one of the most common problems in any widget TV, whether it's electrostatic or electromagnetic. The vertical circuits always crap out. Why? Because low frequency. Low frequency means large value caps. Large value caps, paper caps, are the ones that will be affected most by leakage. So that would probably be that one big old guy there. Well, actually, there's a few caps. I shouldn't quite say that, because this doesn't actually use all the vertical oscillators. Doesn't really use high value caps, so that's not really entirely true. But it does have high value resistors. There's 4 10 meg resistors, but that's in the output, balanced output circuit. The vertical oscillator has a whole bunch of 0.01 microfarad paper caps, 4 to be specific, and uses this blocking oscillator coil. So, a few things. One, I could swap out the 6SN7. That's the easiest thing to do. And I will check the DC resistance on that coil. It better be good. I've had pretty good luck, aside from that Admiral 20B1 I worked on recently, but generally I have very good luck with coils still being good. And I'll check these caps too. So right now, without a scope, I don't know, is the oscillator bad or is the output stage bad? Could be either one. I checked the resistance on the vertical oscillator transformer. It's fine. I checked the resistors around there, and they were a bit high. In fact, every resistor I've checked in this set has been a bit high, about 20-30% high. That's not enough to stop anything from working, but eventually I'll probably be replacing some of them. But then I wanted to isolate, is the problem in the oscillator or the output? So I went and replaced these two caps, the the oscillator to the output, that 0.1 and 0.05. So let's see if that did anything. Also started working on removing some corrosion on top of the tuner. Must have been some moisture that got on it at some point. Alright, we've got some deflection now. Alright. Still no sign of reception though. Alright, let's check out these controls here. Alright, that's size. It's horizontal hold. It's almost trying to walk onto something. Let's check the vertical controls. Let's see this. It's vertical size. Yeah, that's working now. And vertical hold. Let's see, it's weird that both horizontal and vertical size affect the vertical size, and the horizontal size isn't changing. Horizontal hold's doing something though. In other words, horizontal size, it's got too much width now, and this should squeeze in when I adjust horizontal size, and it's not doing anything. Or it's not doing anything to the horizontal size anyways. This kind of makes me wonder, is something miswired? So let's see. This is horizontal centering. It's hard to tell if it's doing anything because I've got so much width. And vertical centering. It's kind of frozen like in the other set. It's like vertical centering's working. This is really hard to turn. Well, this set is certainly behaving differently than the other one was, that's for sure. Oh, I also went ahead and replaced, actually, all the tuner and IF tubes. I swapped them out of the other set that's working, so I don't even have to think about the tubes being good or not. So, we definitely got some major issues going on here. This set is acting weirdly. Alright, well, the troubleshooting will continue. Next, I'm going to check out the horizontal size control, because it's a really simple circuit, and it's not working at all correctly, so it should be something pretty obvious, like maybe a bad potentiometer or something. Continuing on with the troubleshooting, I checked the horizontal circuit and did not find any problems. Everything's wired up. That 20K pot is okay. That 20K pot, this transformer is good. So I'm still not quite sure what's going on with that. I then went and checked all the critical signal coupling caps, like this 0.1 microfarad that couples to the video amp. And I checked the AGC cap and the coupling cap to the sync separator. All of them are leaky at just 100 volts, so they all got replaced. Something else I checked was unexpected. There's 4 tiny 4.7 meg resistors on these controls, the centering controls. Those are the ones you see here. 2 of them measure infinity, open, and the other 2 are way off. So those need to get replaced. The problem is, can't really get at them easily. Now this board, or these pots are mounted on a board, and it's attached, let's see, a small screw there, and one here, and that might be it. What I'll attempt to do is take those screws out and see if I can get this board out. The reason I do that is we got high voltage on here, thousands of volts. So also we got these long plastic shafts, and the board is a bit distant from the chassis. It also makes it very hard to work on. These controls are stiff. They don't seem to be quite responding the way I expect them to. So I think that deserves some further investigation. But before I do that, I am going to try powering it up to see if replacing these coupling caps, that's the one of the video amp there, to see if replacing those fixed anything. So this couples the signal to the CRT, this couples the signal to the final video amp, that is the AGC cap, and that couples the signal to the sync separator. If any of those go out, they could totally kill the signal from going through the set, or all the way to the picture tube, that is. Now so far I've been doing some pretty crude troubleshooting, just using some experience, some instinct, and my multimeter, and that's it. If I'm still getting no video and sound, we're going to kick it up a notch, and we're going to do some signal injection. I'll try to dig up my B&K 1077 and see if we can put some signals into the IF. Oh, I noticed there's a label on the CRT that said top, and I rotated the picture tube, so now we know what's what. It's horizontal and vertical are properly oriented, and that sounds horrible, so let's see. That's better. So that's horizontal hold. It makes sense when I turn that, the squealing comes and goes, because it's altering the frequency of the horizontal circuit. But horizontal size, that's the one that, the only thing it seems to do is affect the vertical, which makes no sense. It's wired in right. I still have no discernible. We're not even getting like static really out of the speaker. The speaker is dead silent. Maybe some really faint static. So all that stuff I just did accomplished nothing. Means we got a more fundamental problem. So I also can't tell if the tuner's working. I can't tell if the local oscillator's running. So signal injection. Well, there's a few things you can do. I mean, for audio, you can inject an audio signal like the grid of the audio output tube, like right there. Or you can go a step back and inject it at that 0.005. Go back further, then you got to do 4.5 megahertz frequency modulated signal. Going back into these stages, you need to do the IF frequency, and this is one of those older sets that uses the like 22 megahertz IF. So I can't use my newer Suncor signal generator. It only does the 44 megahertz IF. But the B&K I've got can do both. It's got a variable IF frequency. Haven't used it in a while. I never did finish completely restoring it, but it worked well enough that I was able to use it in the past. So I think I know where it is. So I'm going to get that out. Here it is, the B&K 1077B, kind of the ultimate piece of test equipment for vintage TVs. They made a number of versions of this. This I think is the last one. I do have one of the earlier ones. 1074 or 75, restore someday, but it has far less functionality. So what can this do? Well, one, it can generate signals, video, just, well, man, where to start? Alright, let's start down here. Video, just plain like composite video. Or a separate sync pulse. You can change the polarity in either one of these. I believe this is a frequency, so basically it'll make a pulse anywhere from 0 to 50 kilocycles, kilohertz. I don't know if this video signal has the sync pulses in it or not, or is it just video? I think it's got sync pulses. Audio, either just 1 kilohertz test tone or 1 modulated to 4.5. Color, yes, you can do color with this. If you turn it off, it's just black and white, otherwise you can adjust the amount of color saturation. This is the output for whether you're doing IF or, well, it's modulated video. I'll get to that in a moment. Bias, so in the past you use a battery to do an alignment. On this you can use a DC power supply, 0 to 25 volts, you can use for doing alignments. This stuff I've rarely needed to use, but this will generate your various sync pulses and plate drive, either solid state, like to drive a transistor on the horizontal output stage, or to drive the plate of the horizontal output tube. So you can go right to the flyback with this. You can also ring a flyback or yoke with this to test to see if it's got shorts in it. And you can do the vertical horizontal drive signals to the vertical horizontal output tubes. Also do the keying pulse, that keyed AGC that I was struggling with so much on that Admiral 20B1. This could have generated that pulse for me if I'd wanted it to. So, RF. It can be any one of these. This can do UHF, channel 14 to 83, IF from 20 megahertz up to about 48 or so. So we're going to be down around here. And or you can do just channels. So this sets the function. No RF, IF, where you use this control. UHF would be this control, or your channels 2 to 13. They skip a few of them, but they give you some of the channels there. And when you do your video, it's not just the usual like crosshatch pattern or dot pattern or color bars. No, this has that cool feature of, you can put slides in here. It's got an ultraviolet CRT and a photo pickup tube. If I put this on, see how it's glowing purple? That will generate a test pattern, and you can put different slides in here for different patterns. I do have a few other slides elsewhere. This has both tubes and transistors in it. As you can see, I have not fully recapped it, and I noticed when I put the scan on this, it didn't cover the whole screen. So, no doubt it's got issues. It's not going down as far, which is the vertical linearity is probably off, but we don't care about that as long as we can get a test signal out. So, I still have this on, so where to start? Well, let's just go right to the IF. And I got audio on, I'll crank the video level all the way up. I got that right around the right level, so I'm going to hook this up to the grid of the video output tube, which is right there, pin 1 of that 6AU6. There is a big capacitor inside of this, so it'll isolate it from DC, so I should be okay with just clipping this right in. So let's give that a try. Alright, here we go. Clip the ground lead on and clip the signal in. Put the level up, adjust the IF. Or not IF, sorry, what am I doing? No, we can't do this. Wrong. Only if I had direct video could I do that. No, this needs to go to the IF, so I'm going to put it this right before the detector. Unfortunately, the connectors for a lot of the other outputs, they're not BNC cables. They're banana jacks. So I got to get different test leads for that. But let's go to the grid of the third IF here and see what that gets us. Gotta figure out where that is. Alright, pretty sure it's this guy over here. So let's give that a try. And put the polarity on it. Let's change frequency a little bit, and we got nothing. Alright, so I'm going to go back. I'm going to get some different cables and try doing the video injection. Turns out my capacitor test leads are perfect for this, so I borrowed them, and I want to hook this up right there. Well, that's doing something. Just flip the polarity. Adjust the level a little bit. Let's see if the sync controls do anything. Yeah, it seems like it's trying to. I'm almost kind of locked right there. It looks like it might be inverted. Yes, it was inverted, or maybe not. Try to turn the contrast down a little. The brightness, rather. And it's so messed up it's hard to say. But something's getting through. So what does that tell us? We know the video amp is basically working. So the problem's further back. Let's put the test tone on. And it is on. Although that's a separate thing. I don't know if you can get a test tone going through. Seems like we should, but maybe we can't. Ah, that's the right polarity. Okay. There, first signs of life out of this set. It turns out I made a mistake earlier. When I was trying to feed the IF into the video IF stages, I forgot to put the RF selector to IF. So right now I am going right to the output of the tuner, the green wire right there. And we've got an image. So it seems like the problem may lie in the tuner again. It seems kind of crazy that both sets I worked on had issues with the tuner. Vertical hold screw. Now this may be the wrong polarity, because generally as you go through the video stages, each stage will invert the signal, and on the RF output this does not have an invert function, I don't think. I also don't have any sound. I believe, yeah, the audio is on. So we definitely got some other issues as well. Well, let's just do one simple thing. Let's try testing the audio. So I'm going to move my jacks on this over to the audio out. Off the ground I can leave in the same spot. And let's... where should we hook up the audio? Let's try... going to one side of the volume control. That should work, I do believe. Yeah. Oh, it's not on. No, nothing. Well, it does something while I got it connected. The buzz goes away. But we're certainly not hearing a test tone. Alright, let's try going to the grid of the audio output tube. Now there are a bunch of caps in this audio circuit that are all the original wax caps. So definitely could be something bad there. So let's see, pin 5, 6AS5. Boy, things are so cramped down there, it's so hard to see what's going on. The audio is underneath the tuner on this set. And it's really hard to get at. So let me get down in there and see if I can hook it up. Okay, I think this is the right spot. Wow, still nothing. Huh. So it's got all sorts of problems. Now, the electrolytic down here is a replacement, and the two sections in it both go to the audio section, and that is also critical to the operation of the set. Now, I'd measured it, and it seemed to measure okay. Got about 120 volt, 5 volts DC. There are a whole bunch of paper caps down in here. 1, 2, 3, 4, 5, 6 of them, all very hard to get at. I had to check a few resistors. There's a 180 that's pretty critical to the operation. The cathode bias resistor, that measured okay. There's a few others, so basically I isolated it down to this tube. And I tried injecting a signal here, and I got nothing out. So could be something here. I mean, the audio output transformer could be shot, but we are hearing a buzz as I'm changing things. And when I would change the channel clunker, there was something, but it's certainly not a rush of static like you would expect. So I'm going to check various things around here. Could also just be the audio output tube. I don't recall. I think I swapped that. I swapped that tube. Or no, I didn't. No, I did not. Well, alright. Don't never overlook the obvious. Maybe it's as simple as the audio output tube is bad. But for sure, this set has a lot more issues than the other one. Whew, it's very hot, but that's normal. Again, every resistor that I check on this is either on the edge of needing to be replaced or needs to be replaced. They're all high. They're all 20-30% high or more. Some are double, triple values. A few of these high voltage resistors in the high voltage circuit measure infinity, as I mentioned earlier. So it will be quite a bit of work to like really overhaul this thing and get everything up to spec. Let's try going in here again. No point doing the volume control because I'm going right to the grid of the output tube. So let's try this side of the resistor. Now I'm assuming that the output of this RF generator is good, that the audio output of this B&K device is good and is the proper level, both of which may not be true. So let me try a dedicated function generator or audio generator. Now this I know works, a WaveTech 183. I did a video on it when I first got it, and I've shown it in a few other videos. It's a function generator on steroids. That can do up to from like 0.001 hertz up to a megahertz. And it can do sweeped and gated and triggered and sine and square and triangle and all kinds of fun stuff. Now this, I do not know for sure, has a cap in series with the output. So I'm going to put one. I know it can drive up to a 50 ohm load. It pretty much hook a speaker directly up to it and get some sound out of it. So I'm going to take a big old cap here to isolate any DC voltage. I'm getting back into it. Which means I need another clip lead. There we go. What is that? It's a 0.68. The value's not particularly critical. I'll just grab the one that was handy. And let's see. Yeah, make sure the level's fairly low so I don't blow my eardrums out. We have sound. That's with maximum output. So I imagine this audio output tube needs a bit of drive. Yes, fun device. I am now going to drop the output level and go back a stage in this. Let's see, let's go to the audio preamp gate, or grid rather. It's going to be a 6SQ7 pin 2, or, well, the volume control. Let's go to the arm of the volume control like I was trying earlier. So that would be right here. Now the volume control is working. Alright, now let's go back to the grid of the 6SQ, or that was the grid of the 6SQ7. So it's so much louder now. So now let's go back to the B and K. And let's try the 4.5 megahertz out. So now I'm wondering, maybe the audio out on this, the B and K, either doesn't work or it's not a significant signal level for what I was trying to do. Kind of stinks. If I grab a scope, I can verify that, I suppose. Although I hope I wasn't just doing something really stupid. I just realized this has 3 power positions: off, standby, and on. I hope I didn't just have this in standby when I was trying to use it. So let's try this guy again. Although I think all standby really does is kill the scanning CRT inside. I think the other functions may still work, so that didn't seem to do anything. Let's try. Yeah, nothing. But let's try the 4.5 out for the heck of it. So that should go. I'll try putting it over here. Pin 1 of the first audio. IF. If I can figure out what tube that is. Alright, that's up in here. So the video is over in this area and the sound is up above the tuner. And the 6AU6 is this guy, and there's pin 1. Well, when I turn it on I get a buzz. That's something. That seems to be affected by the IF, that's kind of weird. I wonder if that's just receiving it via radiation. Go back to RF output. Check this again. Yeah, go back. As far as one can go. Annoying. Well, alright, so what to work on next? There's so many things that are screwy on this. No horizontal width control. No signal seems to be coming out of the tuner for some reason. sound may or may not be working. I could dig up my Sencor RF generator, test pattern generator, because that does a 4.5 megahertz sound. I guess that makes sense to try that, because I know that works. And then the high voltage goofiness with the centering controls and stuff. So, well, one simple thing I'll do is I'll clean the contacts on a tuner. It may accomplish something. I'll do that first because that's the easiest thing to do. Finally, clean the tuner pins, got the volume cranked up all the way. And we have a little bit of sound. But no image. We contrast all the way up, so now it does seem like, oh, well, we do have faint, so boy, I really got to turn the brightness down, and actually there is an image with the contrast all the way up and the brightness almost all the way down. Man, well, that's something. So, it seems like we've got some pretty weak gain going through this set. Like I said, all these resistors are out of spec. Just about. Would that be enough to kill the gain? Maybe. So, for example, on the video output tube, it's a 33 ohm resistor on the cathode that provides a grid bias. It's measuring 60. So it's almost twice what it should be. Will that affect the gain? Yes. And similar to the other resistors going down through here. Now, I haven't checked all of them. All the ones I've checked have been off, but not off so much that I would expect performance to be this bad. So what I think I'm going to do now is I'm going to go through and check all of them. And maybe there is a smoking gun somewhere in here. Maybe there's one resistor that's gone open or shorted or something like that. Otherwise, I'm a bit confused because there are no more paper caps. They're all ceramic caps in here. There really weren't any paper caps to begin with, not in the IF chain. And they're the type of ceramic caps that are very reliable. These tubular ceramic types. There's a few disc here and there, but those are used for like bypass. They're not the main coupling caps. So. And I've measured all the peaking coils and such in there. They all measure good, so I don't think that's an issue. So I'm going to go through and check all these. I mean, all it takes is one stage. So yeah, I mean, when I put the B and K on there, I was able to get an image through. But I had the output level all the way up, and I was going back to like the output of the tuner. So with all the gain going through here, that should have been completely overloading everything, and it kind of wasn't. So I'm thinking the gain has really been compromised. Now, it's also possible that somebody screwed around with the alignment. I hadn't even thought about that. So that's something else that, well, after I've eliminated everything else, I'll consider that. Well, I went through every resistor in the video IF, and just about every single one was off 40 to 70%. So I think that when you combine that through every stage, that the overall gain may be decreased so much that that's accounting for my issues. Because after cleaning the tuner, I can kind of receive a signal, and I can kind of get sound, and there's a picture, but the gain is just so weak. There could also be some components that are off inside the tuner, which are underneath this drum. So, unfortunately, I think this set is going to just require brute force going through and checking and replacing an awful lot of parts. And it's going to be very incremental improvements as I do, so at least I can do one stage at a time on the IF and, you know, see, like, you know, do the first stage, does it get any better? Do the second stage, did it get any better? And if it doesn't, then it's probably not what the issue is. Anyways, I thought for at least the moment I would tackle another issue. So I took out that board. Taking out the two mounting screws, I was able to loosen it up a bit and kind of get at it, but I wanted to really overhaul this thing. So there are the 4 resistors that are just really, really messed up. 2 measure open and 2 way off. So I'll get that out. And also, because somebody had replaced these high voltage caps, they just kind of cut out. They clipped out the old cap and left the lead there and tacked on a new one, so all these lugs are filled with broken off bits of wire. So I'll clean all that stuff up too, and I'll clean the pots and all that good stuff, and have fun remounting it all and hooking up all the wires, because there are quite a few. So the deflection plates connect directly to this board, as do some of the wires going to the high voltage stuff, and all 4 of the caps mount there too. So there's a lot of stuff that connects to this. So got to have some fun hooking everything back up and getting it right. But that seemed like that was the only option, really. You really can't get at these tiny resistors with the thing mounted in there. That's better. I cleaned it up a bit and installed 4 new 4.7 meg resistors. Now I got to rewire everything back in. So the 4 deflection plates on the CRT attached to these 4 points, and some of the other signals connect to these 2. And this is focus. We got to connect 3 things up there. So yeah, got a bit of rewiring to do. While I was able to get down in here, I cleaned up these wires a bit. And there's a 10K resistor down here I'm going to replace. And I can bend all these caps out of the way. The caps all connect to these 4 points, along with the wires for the CRT. So I did take some reference photos. I will double check. Most of these wires go up to the CRT socket right on the top side, which is numbered, and I can refer back to the schematic to make sure I get it right. If I don't, I may cross wire the horizontal and vertical plates, and the picture will look really funky, but shouldn't cause any problems. Focus is easy enough to wire up because it goes to these 2 resistors and I think this wire. Well, I finished going through this area. I finished cleaning up all the pots, putting in new 4.7 meg resistors, and replaced all the high voltage network and put in that VMA cap on the main high voltage supply. And now all these controls work properly. The vertical centering moves it up and down. The horizontal moves it left and right. And focusing works. Alright, I then moved on to all the video IF, detector, AGC, and video amp. Everything checks out, aside from a lot of the resistors being off spec. Everything checks out. The voltages, the resistance readings are, you know, they're a little high, but they're not totally out of whack. The only thing that's a little unusual is the AGC voltage. So they use half of the 6AL5 for the video detector, it goes through here to the video amp, and the other half is for the AGC. And it's real simple. They just rectify the incoming signal, and then this is the cap here to kind of hold the voltage, so it only slowly changes the response to the incoming signal, and it supplies bias to the first 2 IF stages and into the front-end RF amp. I got basically 0 volts. It should be like minus 0.1, or minus 1 rather. I believe the more positive it is, the more gain these tubes are going to have. So it seems like it's trying to boost the gain as much as it can. And The only two possibilities left I've got, because I know if I inject a signal in here, we got a pretty strong signal. What I'm not sure is what are the proper signal levels. So when I got that test pattern, I mean, it was really on there boldly, but I may have been really pushing in a much larger signal than it would normally see. Or I was putting in the proper levels and all this is working right, and the problem lies in the tuner. And possibly the alignment is off, and that's what's killing the gain too. To verify that, I basically need to go do the alignment procedure. It's pretty simple, the tuning on this. So this is a bit different. This set's different in a number of ways, but you know, as I said early on, this is about the most basic TV you're ever going to see. So these stages are not coupled with a transformer. So we've got our plate voltage coming in here, and it's going through a choke, and it's capacitively coupled. So these are basically RC coupled stages. These coils are peaked though, so it's I guess you could say it's stagger tuned. But there's only two tuned stages on it, 25.3 and 23.1, and this one is not tuned. So there's not a whole lot to the alignment. And then, yeah, there's some stuff on the tuner a little bit you can tweak, but that's basically it. So, sorry, that's not quite true. There is one over here. I misspoke. So 25.3, 23.1, and 25.3. This is kind of a crude way to do it. It's not even stagger tuned, really. It's just going to have two peaks. It's going to response will look something like that. I can take my little twiddle stick thing, and there are some threaded brass rods on top, and I can just tweak these each like half a rotation to the left and to the right and see if it makes any difference. You know, short of going through the whole alignment procedure, or I can start investigating the tuner. Now I need to get down in here at some point, which means the tuner's got to come out anyways. So I'm thinking this is as good a time as any. So I'm going to try tweaking those coils a little bit, see if it does anything to the response, and then I'm going to proceed to working on the tuner. Before I unmount the tuner, I thought I would just pop the drum out to take a peek inside. It's pretty easy to do because this has the later retention spring on it, which is much easier to get out than the slightly. Before I completely unmount the tuner, I thought I'd pop the drum out so we could get a look inside and see if there's anything obvious wrong with it. And this one is easy to get out because it's got the newer retention spring, unlike the other set I worked on that had a far more finicky retention spring. Alright, so here's the inside. We've got another spider corpse. Is that a problem? Maybe. Probably not though. Oh, and I did try tweaking all the slugs in the IF. It just made things a little bit worse. So I don't think that's the problem. Well, I tried wiggling these tubes just in case, you know, there was something up with them. And another little spider down in here. So unfortunately, all I can see is one resistor. Now there aren't a whole lot of parts in here. One resistor, one RF choke, probably on the filament supply, a couple ceramic caps that basically never go bad. However, there are some more parts down underneath there, which you really can't get at with this thing installed. So I'll measure that resistor. I mean, you know, never know, it could be open or something like that. But the rest of them, I'll have to unmount this to get at it. It was kind of a pain, but I did manage to finally get the tuner out. You have to unsolder a grounding braid, and then there's 4 wires. Filament supply, plate supply, AGC, and signal out. And the RF comes in, the twin leads go into the antenna terminals on the back. You got to take that out too. So I proceeded to check the resistors. 4.7K is a little high, but nothing too outlandish. 3.9K is okay. It's 47K down in there. It's all right. This 10K it measures about 14K high, but not you know, probably a showstopper. 220K, haven't checked that yet. It's really hard to get at. It's 4.7K, checked that okay. And then I got to this 10K. That goes between pin 6 and 7 on the 6J6, although really pin 7 is grounded, so it's between pin 6 and ground. So that is the grid on... I'm not sure if this is a local oscillator or the mixer side of things. Sharp tuning, it seems like this would be the local oscillator side. Regardless, it's way off. Oops, wrong pin. Pin 6. There we go. I'm used to doing it from the bottom side where you count clockwise. I gotta go the other way around. It measures 89K, or almost 90K. It's a little bit higher than 10K. So, gotta replace that guy. And let's see about that 220. Also, gotta replace the battery in my multimeter. The 220 measures 218, so that's alright. So, I got to get down in there and replace that 10K resistor and then put this whole thing all back together. While I got it out, I'll clean it up a bit. And hopefully that does the trick. I could also substitute another tuner. But for sure I want to try replacing that and see if it does the trick. I replaced that resistor and quickly hooked the tuner back in. It's not all firmly secured or anything, but I'm dying to see if this made any difference. This set has been so frustrating to work on. I think that's better. I do have the volume cranked up all the way, but that picture looks a little more defined than we've had in the past. I think it's a step in the right direction. I do not recommend you go monkeying around in the tuner. That should be your last resort. And the reason being is even just moving a wire a little bit may necessitate needing to tweak it and align it. So since I just went in there and did move some stuff and tack in a couple new resistors, I think maybe it is time to do a full alignment. It's definitely better. I mean, we got a watchable image now. It's fairly stable. This horizontal hold, it seems to lock pretty well. But horizontal width still does not really do anything. And I noticed on the back that it appears to be a replaced control. It doesn't have the same sort of knurled shaft that the others do. So I better check, maybe it's not the right value or something. There's a vertical hold. That syncs pretty well. Vertical height's working. Brightness is working. We just don't have very good contrast. That's again a function of gain. Focus is working. Finally some progress. So it could just be a matter now of I'll need to go through and replace the rest of the resistors in the IF that are so far off, and then go through and do an alignment before I worry about chasing down anything else, because I've checked basically everything I can think of at this point, except for ceramic caps, which are extremely unusual for those to be bad. So two main issues left. Lack of gain, and why doesn't the horizontal width control do anything?